Programming today is an exciting blend of traditional logic and cutting-edge techniques. Imagine you're crafting a recipe. In the past, you might have followed step-by-step instructions, much like writing code line by line. But now, the kitchen has expanded. You can still use algorithmic thinking, our classic approach. But what if you could train a master chef, a neural network, to understand and replicate the recipe with precision? Or perhaps you might simply give instructions or prompts to a skilled assistant who knows exactly how to execute them. This is the power of prompt engineering. Each method offers a unique path to the same destination, showcasing the versatility and creativity in the AI age. As we explore these techniques, remember, programming is no longer just about code. It's about harnessing the right tools and thinking creatively to solve problems. So why study multiple programming paradigms? Programming isn't one size fits all. Different tasks may call for different paradigms. Let's explore this using a simple example. Finding the square root of a number. We'll compare three approaches: classical algorithm, using a neural network, and prompting an AI, to see how each method uniquely tackles the problem. Just as picking the right language to solve a problem in the classical approach, in this new AI age, we may have more options beyond just programming languages. Our classic algorithm for finding the square root is based on the idea that if we guess x over 2 to be the square root of x, we can then keep adjusting the guess until the difference between the guess squared and x is less than a very small number, 10 to the power of 10, making the error negligible. Here, we use iterative refinement, math, and logic to understand the properties of the square root. Then, we do it in a way that allows us to explain to someone why the algorithm works. In our second approach to solve the same problem, imagine teaching a neural network to understand square roots. First, we generate pairs of numbers and their square roots. Then, our neural network learns this relationship, aiming to predict square roots accurately. Finally, we test its predictions, checking how well it approximates this mathematical function, just like a student learning a new concept. Here, we use TensorFlow to build a model with just 2 layers. Our inputs range from 0 to 100, and the network learns over 100 epochs. We can change, increase, or decrease the number of layers to see how it affects, for example, the accuracy of the output. This setup helps the model predict outputs efficiently using the Atom Optimizer. The model, once trained, can be used to estimate the square root of any number. It may not be as accurate as the traditional method, but it demonstrates the power of a neural network to compute any function. So how does a neural network learn? Imagine teaching a car to drive by showing it millions of road trips rather than giving it explicit directions. That's a neural network. It learns from data, not set rules. While it can generalize well, it's not perfect. Its mysterious black box nature and hunger for data and computing power present challenges. These are some of the drawbacks of using a neural network to compute the square root function, which is well defined. However, for complex functions, neural network may be the answer. Now the ChatGPT has taken AI to general public. You speak to a LLM using English instructions, which we call prompts. You are not interested in how it solves the problem, but only that you solve the problem. By prompting a large language model like ChatGPT, you can generate Python code to find square roots using Newton's method, making complex programming tasks feel like a breeze. You may not need to understand the code at all, but you need to know how to run the code using some IDE. That is all. Most people can easily learn how to do that. When using an LLM to solve a problem, it is like telling a computer to build your dream house without needing to explain blueprints or construction. That's what large language models do. They understand language patterns to quickly create solutions. Instead of coding, you just need to master prompt literacy, making it the fastest way to start your project. Now, let's compare all three approaches we discussed based on control, accuracy, explainability, learning, and use cases. Each approach has its own advantages. You can explain a classical algorithm, prove its correctness, and ensure it will always work as intended. On the other hand, we cannot really explain how it calculates the square root, but it does. Maybe you're okay with that. You have some control over the number of neurons to increase accuracy, etc. But it is still a black box. On the other hand, using prompting to solve the same problem has many issues. Based on the LLM and given conditions, the accuracy can vary. LLMs are not deterministic. They can give different answers to the same prompt. This is a huge disadvantage. However, it can help solve problems, even if you are not a technical person. You just need to know how to ask the right question and verify the answer you got. So, now what are the key takeaways from this presentation? Algorithms are like clear instructions for solving a problem. Neural networks use past experiences to train a model to solve the problem, while large language models quickly suggest creative ways to solve them. You need to master the prompting language to get the best out of LLMs. Some call this vibe coding. Interesting way to describe a new way of coding. Mastering these techniques makes you a skilled, adaptable programmer, ready for any coding challenge, whether you actually write code or just use the code written by a LLM after verification. Now, it's your turn. Dive into solving tasks like finding x cube or logarithms using 3 different methods. As you work, consider the strengths and weaknesses of each approach. This will help you understand when to use each method for the best results and deepen your problem-solving skills. Please comment on what you think of this. Should this be taught? Can this be taught? Some really interesting questions to think about.